Okay, welcome to Friday. Go ahead and get out your homework. Steadily moving on. Here we go. So let's see, 1 through 12 all, and then 17 through 24. Clearly, I didn't like 13 through 16. All right, number one. Remember, this is the distance, so it should be units involved, but since we're dealing with the coordinate plane, we skip the units. So the distance for number one is 7, number two is 5, number 3 is 4, number 4 is 5. All right, number 5 is root 10, square root of 10. Number 6 is 2 root 5. Number 7 is 10. Number 8 is 13. Number 9 is 2 root 13. Number 10 is root 130, square root of 130. Number 11 is 5 root 2. And number 12 is 4. All right, 17 was dealing with that formula for a circle. So you're finding both the center of the circle and the radius just from looking at the formula. Not too challenging. Just remember the x and the y would be opposite of what's in the formula. I think 17 was actually the most complicated one because it just simply said y squared. Well, remember that would be y plus 0 squared. So that was kind of the hint there. So 17 is negative 3 comma 0 is the center, and the radius is 7. Remember, you take the square root of the what's to the other side of the equal sign. Number 18 is negative 7 8, and the radius is 6 over 5. 6 over 5. Take the square root of that fraction there. Number 19, let's see, the center would be at J, negative 14. That one's a little weird. And the radius would be the square root of 17. And the last one for that particular one, 20, is negative a comma b, and the radius is c. All right, and then the last four, you're supposed to write the equation. All right, so number 21 would be the quantity x minus 3 squared plus, now if you put y plus 0 squared, that's fine, or if you just put y squared, that's fine as well, equals 64. All right, 22. So if you put x plus 0 quantity squared plus y plus 0 quantity squared equals 36, that'll work. But just remember x plus 0 quantity squared is just x squared. So x squared plus y squared equals 36 would be the more concise form. 23 would be x plus 4 squared plus y plus 7 quantity squared equals 25. And the last one, x plus 2 quantity squared plus y minus 5 quantity squared equals 1/9. There you go. All right, count up how many you got wrong and answer question 1 on the Google Forms. Okay, let's take a look at the calendar. It's Friday. We got Monday off. We'll finish the book next week, 2 lessons, and then we'll move right into this review for semester final. Remember, your semester finals start on that 3rd week on Friday with your English comp. Then we have that 3-day weekend with Memorial Day. We come back on Tuesday. Tuesday will be your science, your biology final. Wednesday will be your Latin final. And Thursday will be your math and English lit. So you're doing 2 tests on Thursday, English lit and math. And then Friday will be your history final, and you're done. All right, here's your homework. Copy it down. All right. So we have actually reviewed this year. Way back first quarter, we did a review of this. This is well, I guess they do this 2 things. One, they want to kind of I don't know, nudge you back into the algebra mindset for next year when you take algebra 2, and then 2, I guess they're trying to show the connection between geometry and algebra. So it's basically slope of the line. There is absolutely nothing new that I will show you today. It is 100% a review of what you should have learned in Algebra 1. Okay, so yeah, it is absolutely a review. So just remember that this concept of slope, slope is defined as how steep a line is, or the steepness of a line. So in red there are 3 different lines, and notice they each have different steepnesses, right? But that's, the word steepness is not a very rigorous word to define slope, so we are going to use the more mathematical explanation of slope, right? So the mathematical explanation of slope, M for slope, little m, italicized lowercase m, is the change in y values over the change in x values. In other words, you've heard this many times from your math teacher, rise over run, right? There are two methods for calculating slope. One is, well, this is my term. I call it the monkey method because it literally is so easy you could teach it to a monkey, not that you're monkeys. Oh, by the way, those were apes. Here we go. This is called the monkey method. You'll be given a line, the red one there, and you will be given 2 points on that line, the blue and the green points right there. To calculate slope, you simply calculate how many squares or lattice points it takes to go from the blue dot to the green dot. If I go from the blue dot to the green dot, I rise, let's see, 1, 2, 3, 4, 5, 6 lattice points or 6 squares above. If you go up, it's positive. If you go down, it's negative. And then from that point right there, I would have to go to the right. Right is positive, left is negative. I would have to go to the right 1, 2, 3 squares or lattice points to the right. So the run is 3. Rise is up and down, run is left and right. Just remember, if you go up, it's positive. If you go down, it's negative. If you go right, it's positive. And if you go left, it's negative, just like the number lines, which make up the x and the y axes. Okay, you do need to reduce your fraction, so the slope, or m. Now, the word slope and m literally mean the same thing, so that literally says slope equals 6 over 3. So usually we just write m, and absolutely as we move into Algebra 2. 6 over 3 reduces to 2. So we got the slope, m is equal to 2. m is equal to 2. All right. Once again, I'll give you a line. I will give you 2 points on the line, and you simply calculate the rise. And remember, it's rise over run. That's alphabetically top to bottom. So if you forget which one is rise and which one is run. So go from blue to green, we have to stay on the little black lines there that make up the coordinate plane. So it looks like we go down 2, so that would be a -2. And then from that point, we would go to the right 1, 2, 3, 4, 5, 6, to the right +6. So we got a -2 over +6, which is -1/3. All right, hopefully that is not new to you. Now here are 4, take time, do this calculation quickly for me. 2 of these I gave you 2 points, and on 2 of those blue lines there are not 2 points, so you will have to choose a point. And remember, you must choose a point where the blue line goes through a lattice point. The lattice points are those points formed where the x's and the y lines come together, right? All right, so the first one, there are 2 points there. So if you take a moment and count those squares or the lattice points, it looks like you're going down 3 and down 3 and right 4, so -3/4. On that bottom left one right there, notice there aren't 2 points, so you must pick a lattice point. Notice that is a lattice point. That is where the blue line crosses 2 of those black lines. Right? You can't just choose any 2 points. You must choose lattice points. So right there, I chose another lattice point right there. So let's see. If I go from the left dot to the right dot, staying on a black line, I'm going up 3, 1, 2, 3, and right 2, so 3 over 2. On the upper right one, notice once again I don't have 2 points, so I need to pick 2 points. I think my animation is out of order here. I'm going to show you the other answer. Okay, there's my 2 dots. So I'm going down 1 and right 3. Okay. Lastly, on that bottom right one there, that I already showed you the answer there. I gave you 2 points, and look, the slope isn't 1 when you initially count the squares. It looks to be up 4, right 4, but 1, 2, 3, yeah, up 4, right 4, but 4 over 4 reduces to 1. Make sense? Hopefully that's not new. All right, moving on, graphing lines. So here's the game we're going to play. This is straight from Algebra 1. I'm going to give you a point. I'm going to give you a slope of the line that goes through that point, and you are going to graph the line. So it says sketch the graph of the line that passes through the point 1, 2, and has a slope of 3/5. The process is simple. We graph the point 1, 2, and then we apply the slope to that point. So remember, slope means rise over run. So looking at that slope of 3 over 5, we would go up 3, right? Up 3, and then right 5. So up 3, right 5 would be there. Now, if we wanted to go in the other direction, the opposite direction, we would do the opposite of each one of those numbers. The opposite of 3 is -3. The opposite of 5 is -5. And think about it. A negative divided by a negative is a positive, so it's still 3/5 there. But from that initial dot at 1, 2, we would go down 3 and left 5, and notice there's another point. Now, just so you know, remember way back when, this was chapter 2, I believe, we defined a line as any 2 points define a line. So you only need 2 points. I had you graph 3 there, but just so you know how to go in both directions there. Make sense? Okay, so one more here. Let's see. Sketch the graph of the line that passes through 0, 5. 0, 5 is right there. And then it has a slope of negative 2/3. So when the slope is negative, right, when the slope is negative, you need to apply that negative to either the numerator or denominator. It is your choice. I'll just, for the sake of argument, I will apply it to the numerator. Negative 2 over 3 is negative 2/3. But remember, we need to do rise over run, so we need to know where to place that negative. So from that initial dot there at 0, 5, we go down 2 and right 3. Technically, that's all you need. But if we want to go in the other direction, right, we would do the opposite of that slope. The opposite of that slope, opposite of negative 2 is positive 2. The opposite of positive 3 is negative 3. So from that original dot there at 0, 5, instead of going down 2, now we're going to go up 2. Instead of going right 3, now we're going to go left 3. There's your other dot. So that's how you move in either direction. And it's your choice. And do remember, in geometry, we've defined a line. Any line is defined by 2 points. Okay. All right. So there. Don't forget to draw the line that connects them and put arrows on the end. Okay. So go ahead and grab a piece of graph paper and do these 3, please. All right. Well, let's see. The first one, I'm going to do these rather quickly. The first one, the point is at 3, 4. So there's 3, 4. And the slope of 1/2. So up 1 over 2, or the opposite, down 1, left 2, play connect the dots. The middle one, first point is at negative 2, negative 2. Let's see, the slope is 3, so write that as a fraction, 3 over 1. So up 3 over 1, or the opposite, down 3, left 1, play connect the dots. And the last one, oh, this goes to the origin. So let's see. Negative 2/3, so I'll put the negative on the numerator. Negative 2, so down 2, right 3. Or the opposite, up 2, left 3. So there's our 3 dots right there. Play connect the dots. Make sense? Okay. So what have we noticed about the slopes? The slopes that go from left to right, go from a inferior position to a superior position. In other words, it looks like if you're going from left to right, you would be climbing a mountain. Those all have positive slopes. And the opposite, if you go from a superior position to an inferior position from left to right, it looks like we're going down the hill. Those slopes are negative. So keep that in mind when you look at a line. Any line that goes upwards from left to right has a positive slope, and any line that goes from left to right that goes in a downward direction has a negative slope, right? So what we're going to do right now is we're going to calculate slope without graphing. So hopefully you remember this from last year, and we also did this in, well, I didn't do this with you because I wasn't your pre-algebra teacher, but if you had a good pre-algebra teacher, you did this also in pre-algebra. They had a formula to calculate slope. So if I didn't have on the left there a picture of the line, right, how would I calculate slope? So some of you probably do remember the slope formula, but this is where it comes from. No, we're not making the Pythagorean theorem right here, but notice there on the right, I have 2 points, x1, y1, and x2, y2. And remember, now this is partially not from the Pythagorean theorem, but the same logic behind it. If we want to know how far we go left or right, well, that's the x-coordinates. Remember, we said that would be subtracting the x-coordinates. And we said if you want to find how far you go up or down, that would be subtracting the y-coordinates. Now, slope is rise over run, and rise would be dealing with your y-coordinates, and the run would be dealing with your x-coordinate, which is why the slope formula is m is equal to y2 minus y1 over x2 minus x1. And you're like, well, don't we need to use absolute value? Well, no, because remember, the reason we used absolute value before is because we were using the Pythagorean theorem. And we're not calculating distance, we are calculating slope or the steepness. So we don't need absolute value this time. Okay. How does this all work? Well, you typically are not given a picture like this. This is just going to show you. Now, from the picture, you can tell that the slope is positive. That's one way to check this if you're given the picture. If you're not given the picture, right, well, you have to think about the coordinates in your head, you know. All right, so let's see. The 2 points are 3, -1, and 5, 4. We know the slope formula is y2 minus y1 over x2 minus x1. As always, when you use this formula, write the points out and then apply labeling so you don't screw this up. It doesn't matter which one's point 1 and point 2. I'll just make the one on the left point 1. So x1, y1. Remember, it doesn't go x1, x2. It goes x1, y1. And the second one is x2, y2. Okay? All right, well, let's see. We'll plug the numbers in. So y2 minus y1. So that's negative 1 minus 4 over 3 minus 5. See what I did there? All right. Negative 1 minus 4 is negative 5. 3 minus 5 is negative 2. Negative divided by a negative is a positive. So the slope is 5 over 2. Okay. And that is as expected. We can see that the slope of the line is positive. All right. Here's another one. Clearly, the slope is negative. So let's see. Let's make sure we don't make a mistake here. So slope formula, right? Throw the points out there and then label. Make sure you label x1, y1, x2, y2. And then toss in those values. So let's see, we need y2, that's 2. 2 minus 5 over 7 minus minus 2. Two negatives make a positive. 2 minus 5 is negative 3, so we get negative 3, and 7 plus 2 is 9. That's negative 1/3. Right. When you write your final answer, it is customary to put the negative in the middle. Okay, we got this? I thought so. Think about this. We just talked about, well, that line has a positive slope. This line has a negative slope. Vertical lines, hopefully this is in your memory banks. Vertical lines, the slope is, and horizontal lines, the slope is. Okay, maybe we do need to review this. Okay, so let's think about this. If we apply the slope formula to any vertical line, right, any vertical line, that's why the points are x1, y1, x2, y2, because I don't know which numbers we want to plug in, but I do know the line is vertical. Think about this. If the line is vertical, which numbers are changing, the x's or the y's? For vertical lines, the x values stay the same, but the y values change. So if we were to plug that into the formula, we would have a different number for y2 and a different number for y1. But since the x values don't change for vertical lines, well, then it would just be some number minus itself, which would be 0. And since we know we can't divide by 0, this is why we define vertical lines of having no slope. It's undefined would not be a wrong answer, but typically we just say no slope. No slope doesn't mean a slope of 0. It means it's undefined. Contrast that with a horizontal line. What's not changing on horizontal lines? On horizontal lines, the y's don't change, right? They both would have the same y values, right? You never go, that's the definition of a horizontal line, right? The y value stays the same. What's changing is the x values. So now we're not going to get a 0 in the denominator, right? Because the x values do change for horizontal lines. But the y values remain constant. So you would get 0 in the numerator, which is fine. Any number, 0 divided by any number is 0, which is why the slope of all horizontal lines is 0. All right. So there is, like I told you, this book kind of ends with a whimper, not with a bang, right? So this was straight up review, all from Algebra 1. Oh, and bonus, guess what you're going to do in Algebra 2? That's right, you're going to review this one more time. So the nice thing about Algebra 2 is it's definitely new stuff, but I'm rounding here. A third to a half of the book is a quick review of Algebra 1 concepts. So you guys will already be ahead of the curve here for Algebra 2. All right, so that's all we did today. This is your homework. If you have any questions, feel free to send me an email. And remember, there's no class on Monday, so I will not be sending you any emails on Monday. I don't know about the rest of the teachers, but I'll work on Monday. So if you have any questions or whatnot, feel free to send me an email. All right, see you guys on Wednesday.